Let's take a look at a root crack. This weld specimen is 0.625 inches thick, and it has a crack. This is the upstream side, downstream side. Here's the center line. We have a crack on the downstream side, and it's right at the root. It's open to the surface. That crack goes all the way down to the ID, or the inside surface, inside diameter of this. And for examining the root, your 70-degree is a very good angle, because with the first leg we can probably get down into the root, and definitely in the second leg we can come up and catch the tip of it. So the 70-degree probe is 70-degree transducer is very good for examining root type of defects or ID connected defects. So the tester, my Epic 1000, I use an IIW block to calibrate, and I use the 0.6 deep side drilled hole and set that as my reference at 80% full screen height. And that happens to be 75.1 dB is what it takes to make this 70-degree probe come back with a 80% full screen height for my reference. This is a 70-degree probe, 4 megahertz, 10 millimeter diameter transducer. So let's take a look. Right now I'm just scanning at reference level because the dB is pretty high, and you can see this grass, this kind of noise down here. We're running pretty hot, but this is a good area of the weld, going back and forth, and that is our root signal. And one thing you'll notice, and then let me pull back, see if I can see the far toe. I'm really not seeing it. One thing you'll notice, the higher the angle, the less reflection you'll get from geometry. Your geometry will be a lower amplitude signal. So let's take a look at this weld scan, and let's see if we can find that root crack. Boom. Look at that. That is, and we're scanning at our reference gain level, and look at this thing plots right there at the root, at the very bottom. The depth is 0.625 inches, so it shows that we are open all the way to the bottom. It plots to the root, and you can see the amplitude. It's booming. Let's rotate it. See the facets. Let's look at the start stop. That's a very high amplitude signal. Move the probe away from us. See some of the facets? We're seeing facets of that crack. Boom. It's gone. We're out of the defect. We're in clean metal now. Let's come over into the indication, into the crack. Keep coming towards us, and then bang, goes away. Distinctive start stop. See it? Faceted. Plots right to the bottom of the weld. As I move back and forth, we can move this guy up. Right now, that root crack, you can see with a 70-degree, there's what they call a lot of walk. I can move back and forth, and this up in the second leg, right here on that crack, up towards the tip of it, right there. On the second leg, I'm bouncing up. I'm catching the top tip of that crack up in the second leg. Let's take a look from this side and see what we have. And I can see it here a little bit, not nearly as strong as it did on the other side. You see where my probe is positioned to the weld. It's quite close to the toe, meaning that this defect is further out this way. I have to move this probe up to see it, but I can see it. But with attenuation, not quite the amplitude, but you can definitely see it, and I can see that it plots to the bottom of the weld, to the total thickness, so I can see that it's a root defect. So look at the position where I am here. I'm catching at the very bottom of that defect, and then let's look over here, and you can really see it. Matter of fact, I'm going to remove 6 dB. I'm going to drop my signal down 6 dB, and still you can see a very good signal. Right here, tracks right to the bottom of the weld. As I push forward with in my first leg, I can walk it right up to the tip of that. But even with 6 dB low, 6 dB out of my gain, you can see very strong signal plotting to the bottom of the weld, right in the root. Let me go back to my reference level, and you can see. Let's rotate this probe. See those facets in the weld. See them. As you rotate back and forth, very jagged, sawtooth type of signal indicates that we've got a crack.